Okay, I screwed something up. I said these were unit vectors and led to something untenable that didn't, from which this didn't follow. This is a correct expression, but let's make them. Without thinking, I made these unit vectors and finally realized there's something screwed up. So let's fix it. Okay, again, your surface is a graph of z equals f of x, y. So here's a picture. Here's your typical parallelepiped. Here's the surface region that approximates the area of the surface of this function, okay? Or the region above the delta x, delta y increment that's on the surface, okay? So for small delta x, delta y increment, this is very close to the surface. We want to find the area of this in terms of the function and its derivatives. We have our sample point xi star, yj star. So here's your sample point. So here's a point on the surface. And we have tangent vectors. Okay? Tx is a tangent vector in a plane parallel to the xz plane. It's got the right slope. The slope has to be fx, right? So any vector parallel to this vector will have a rise over run that's proportional to fx over 1, which is fx, which is the slope it has to have if this is the partial derivative, right? And similarly here. So this vector, and we've seen this, we saw this maybe 2 months ago, that this partial derivative is the slope of this segment in a plane parallel to the yz plane, and the slope is going to be rise over run, which is again fy, so that's correct. Okay, so we have our tx and our ty. So now, tx cross ty. Now, I guess one other thing I wanted to change here, I've got this n here. And that would be a normal vector, so I'm going to leave it as n. Okay, it's normal to the surface. Magnitude of n is easily calculated, and I kind of do that over here, okay?
N isn't an...
If I do tx cross ty, I get this. Since now we're calling that n, its magnitude is this, and that's trivially easy to verify. And we've seen similar expressions.
But that's not the unit vector?
No, I'm not calling it a unit vector now. I called it a unit vector before because I called it, see, I specified that these were unit vectors and I shouldn't have. Okay, you get a simpler picture as you're going to see. Now that I've confused you, you'll see how simple it is. I'm not sure that works. But anyhow, we have this, and this magnitude is okay. Now, n makes an angle that I'll call gamma with the k vector, with the z direction. Okay? And as I said before, but I'm not, I think I'm not going to post that video. Okay? Because I was messing all this up. Okay, gamma, the angle between n and the upward direction, k direction, is well, let's say the cosine of gamma is n dot k over the magnitude of n times the magnitude of k, which just equals n dot k over the magnitude of n. And what's n dot k? Well, n would be the cross product. Okay, that's this vector, tx cross ty. Here it is. What's its dot product with k? Well, it's just 1. You know, k dot k is 1, k dot I and k dot j are both 0. Okay, so that would be 1 over this. Now, simple picture.
Wait, how's that one?
I keep wanting to come back to reciprocal of cosine gamma, which is what I'm getting to. It's not a reciprocal, it's just this. Sorry. No. How is n dot k 1?
Yeah,
What's k dot k?
1,
What's k dot I?
0,
What's k dot j?
0,
What's k dot all this?
1.
Yeah, that's how.
Okay.
Okay? And the magnitude of n is this. Okay?
Okay.
N is this vector. There's its magnitude. So here's our picture. Here's k, and looked at in the plane of k and the n vector. Whatever the direction of the n vector, okay? It projects onto k, projection's just 1, right? Projection's just a unit. The scalar projection is just 1 or negative 1, okay? And since the scalar projection could be negative 1, I've got to take that into account, magnitude of n dot k. Gamma doesn't care whether it's perpendicular this way or the, it doesn't care whether n is up here or down here. The angle gamma is still the same. Okay? Okay, so
Is
here's your n, here's your k. Now if your n is in this direction, I should have drawn this over a little further so I could project it downward. Means your surface is in this direction. Let me redraw that because it's very simple to draw. I was going to do it in 2 pictures and I realized that would be stupid.
Isn't gamma your angle between your positive z-axis and your vector?
Doesn't matter. It actually